Hi guys, here's our math help video on these kinematic equations. This is from page 7 of our water bottle rockets lab. Let's take a look. All right, so just a quick reminder, what are the kinematic equations? These are equations that we use to describe motion. Previously, when we talked about free fall, we saw the simpler version of the equations, but they were the same equations ultimately. Our procedure for solving these problems is the following. Read through the word problem, write out the terms you know, write out the term you want to solve, draw a picture, determine the equation you need, and solve by substituting known values into the equation. All right, let's read our problem first. This is question 8 on page 7. An arrow is shot downwards with an initial velocity v equals 30 meters per second. After a total of 2 seconds, how far has the arrow gone? All right, so step 1, we've read through the problem. Step 2, we're going to go ahead and write out the terms we know. So we know initial velocity, v naught, this initial velocity, is 30 meters per second. We also know that a time of 2 seconds has passed, so change in time is 2 seconds. We also know something else. Our object is falling, therefore the acceleration due to gravity is 10 meters per second squared. All right, step 3 is to write out what we want to know. Delta x is equal to what? Step 4, let's draw a diagram. So we have an arrow shot downwards. Okay. And we want to find the height from the start to the height that it's gone, a total of, who knows, over the course of 2 seconds. All right, step 5, we're going to go ahead and write out the equation. So we want something that includes, say, our acceleration. We want something that includes time and initial velocity. That would be this guy right here, right? We have initial velocity, time, acceleration, time. So let's go ahead and write that out. Change in height, displacement, change in position, is equal to initial velocity times delta t. So that's the initial displacement we get from our original velocity, plus the displacement we get from our acceleration. All right. This term, acceleration, is actually g, the acceleration due to gravity. All right, step 6, solve. Okay, so delta x is equal to v naught, 30 meters per second, times 2 seconds, plus 1/2 times 10 times 2 seconds. All right, we get 60 meters plus 20 times 1/2, 10 meters. So our answer should be 70 meters. All right, not too bad, hopefully. Let's try another one. Question 9. What is the final velocity of an arrow from the previous question if it is at a vertical displacement of 12 meters from its starting height? Okay, so step 1, we read the problem. Step 2, we want to write out what we know. All right, so we have our vertical displacement is 12 meters. Okay, from the previous problem, we also have v initial is equal to 30 meters per second. We also have g is equal to 10 meters per second squared. Okay, notice how we're keeping these all in the positive, so technically they should all be negative. All right. Next one, step 3. So what term do we want to find? Well, final velocity is equal to what? Step 4, we write out the equation. So we want something that includes acceleration, something that includes change in height, change in position, and something includes initial velocity. That looks a lot like this one here, right? So we go ahead and write that out. V final squared equals v initial squared plus 2a delta x. All right. What we have there then is v final equals the square root of v naught squared, that's v initial, plus 2. A is actually g, the acceleration due to gravity, because this is acceleration. Our acceleration is acceleration due to gravity. And we have delta x. All right, step 5. Oh, we skipped a step. Step 4 is actually to draw our situation. Same thing as before. We have an arrow going downwards. In this case, we want to find the final velocity. Step 5, we would write out our equation. That's what we did up here. Let's go ahead and solve. Skipping to step 6. Okay. Solve. V final equals the square root of V initial. V initial, we said, was 30 meters per second squared, plus 2 times acceleration to gravity. Again, this is negative 10 meters per second squared, times negative 12 meters. Okay, so we get 30 times 30. That would be 900 meters squared over second squared, plus 120 times 2, 240 meters squared over second squared. Notice how the negatives have all gone away because we have negatives times itself. All right, so we're end up with the square root of 1,140 meters squared over second squared. And you can go ahead and box your answer there. Okay, not too bad. Last problem. We're going to not do 11 and 12 from page 7, just 8, 9, and 10. A car has an initial velocity of 20 meters per second. After a time of 12 seconds, it has a final velocity of 34 meters per second. Excuse me. Provided the car drove in a straight line east the entire time, what is the displacement of the car from its starting position? Okay, so step 1, we read. Step 2, let's write out what we know. V initial, V naught, is equal to 25 meters per second. T equals 12 seconds. V final equals 34 meters per second. Okay, from this, we could solve for A. Remember, A is change in velocity over change in time, so we could have V final minus V initial over our change in time, T. Okay, I don't think we'll have to do that though. Step 3, let's take a look. Says, write out the term you want to solve for, delta x. Okay, so let's see if there's an equation in just a minute. After we draw, let's draw our diagram. All right, our car is just moving down. We want to find his delta x over that interval. All right, step 5, determine the equation you'll need. This equation up here has V initial, V final, delta t. All right, this is for an equation. All of these are for equations where objects are constantly accelerating. All right, and so we have delta x, or displacement, change in position, is equal to 1/2 times V initial plus V final times delta t. All right, step 6, let's go ahead and plug in. Delta x equals 1/2 times V initial, 25 meters per second, plus 34 meters per second, times delta t. Delta t is 12 seconds. All right, we're going to get a funky number here. We have 34 plus 25, let's see, 59 meters per second, times 12 seconds. All right, we'll leave it in this ugly form, but we have 1/2 times 59 times 12. Notice how the seconds cancel, and you're left with meters. Okay, one last thing to do. We remember that directions in physics are shown with positive and negative. In this case, we said we went east the entire time, so we're going to say delta x is equal to this east. All right, the assumption that we'll make in future problems is that assuming it's positive, which it is, then that would be to the east. Okay, but since this is displacement, we go ahead and write out the direction as well. All right, that's it for now. Again, questions 11 and 12 don't have to worry about. Once you've done that, you've finished the homework. So good job, guys. We'll see you in class overall. All right, adios.